Hey guys, welcome back to another video. It's been a while I made a video on YouTube. I've been busy with work and all of that. But for today's video, we're not going to be doing, some coding. We're just going to be talking some aspect of database and system designs. I just want to explain to you the difference between an SQL database and a NoSQL database. And this is not just like basic difference, like discussion of basic difference. This is more like giving you like a practical approach, giving you some use cases of when to use SQL, when not to use SQL, that is when to go for NoSQL databases, and also making you understand the constraints, the benefits, the pros, the cons, things you should consider when you're building an application and you have to choose the database you should use. There's this thing that most developers do whereby we just use database we love to use, but when building an application and for the fact that you want the application to be scalable, you don't choose database based on the database you like. I cannot always choose a Postgres database just because I love the way Postgres is structured. I would not always need to choose a MongoDB database just because I love the way MongoDB is structured, or I just love the interface that it gives me. I should be able to choose a database for my application based on the kind of application I'm building, the kind of data I'll be working with, the kind of logics I'll be implementing. There are several things that you need to consider before you make use of a particular database. And that's what I'm going to explain to you today. So I'm going to be giving you some practical approach. I'm going to be sharing like a database view schema with you, explaining to you what makes these two kinds of database different and why you should use one over the other in a particular kind of application. I think I've explained, in details what we're going to be looking at. So let's go straight into considering some stuff, like showing you some schemas, showing you some diagrams and all those kind of stuff. So let's do that right now. All right. So first of all, I want you to understand something. When we talk about database, NoSQL and SQL database, it's like pretty straightforward. Now, SQL databases are basically structured language, like structured query language, and NoSQL is like the opposite, which means it doesn't have like a particular kind of structure which it takes. And an example of what you see on my screen right now is an SQL database, which this is Postgres, and as you can see, like just looking at this, it gives you like an approach, making you understand that okay, this is a structured schema. This is a database that has to do with key and values, whereby you can only be able to input an ID here, a username, an email, and each of these things have their own fields which they expect you to submit. Now, one thing we need to consider in database is the data storage model. Now, the tables of SQL databases has got fixed rows and fixed columns, while that of NoSQL databases are basically JSON documents. We've got key value pairs, we've got white columns, we've got tables with rows and dynamic columns and all of that. I'm going to give you a very simple example. Now, looking at this schema, the user schema in this database called NestDB, you can see that we have a database with a table of schema, with a table of users, and the users has its column as ID, username, email, password, which we can also refer to as attributes. All right. Now let's take a look at that of the NoSQL database. If we open up MongoDB, and this is an example of MongoDB, and let me open up the users, and you can see from here that our MongoDB database, for the created events, we're able to submit like a JSON kind of data, and that's something that MongoDB database has an edge over the normal SQL database. For you to be able to submit a data or a value like this in MySQL or SQL databases, you definitely would want to be doing stuff like stringifying the data and having to JSON.parse the data when you get the data back from the database. All of those kind of hectic approach. But that's something that in NoSQL, it's pretty straightforward, and you can be able to design your database attributes or column to accept any kind of data, be it JSON, be it array, be it string, whatever it is, it can be able to accept that. Now, one other thing we're going to be looking at is the general purpose. Now, the primary purpose for SQL databases is basically general. Now, what I mean by that is, if we are to be very, blunt and honest, a MySQL database or a PostgreSQL database or an Oracle database, whatever it is that is an SQL family, would always, to a point, at least to a percentage, to a high level percentage, would always fit into any type of application. But now, there will still definitely be some applications whereby those databases would be difficult to work with. Why that of the NoSQL basically has the general purpose approach, which means you can be able to use these databases for general purpose, but are basically used for storing and working with data that are complex. Now, for example, if you're building a ride hailing system where you have to, use the graph and the trees to be able to set up your data, the algorithm process where you have to book a ride, you have to find how many drivers are available. In an application like that, I wouldn't want to make use of an SQL database, and it's pretty straightforward. Why? Because the data manipulation would be very hectic for me. I can already see that I'm going to be dealing with nested data. I'm going to be dealing with arrays of arrays, arrays of object, nested arrays in nested object. I'm going to be dealing with deep and dynamic data. And this is something that the SQL data still does not support holistically, like 100%. But it's easier done in the NoSQL, which is why I said earlier on in the video that when you're making use or when you're choosing the database to work with, you should consider a lot of constraints. You should consider a lot of things. What kind of application am I building? What kind of data will I be working with? Are my data pretty straightforward and primitive? Are they something that would just expect me to, have a string here, have a number here, join a string and a number together if that would be needed? Is it just pretty simple, or does it require me to always concatenate, to always convert objects to array, to always save key value pairs and documents in my database? When you do this comparison, you can be able to tell that, okay, for this application, I'm going to be working with MongoDB. I'm going to be working with Amazon DB. I'm going to be working with Cloud DB or Couch DB. I'm going to be working with MySQL, Postgres, and that's that. Now, in terms of the schemas, the schema of the SQL database is very rigid. Rigid in the sense that it's not straightforward to change the schema. Now, let's take for example, we've got the user schema, which has the ID, the username, the email, the password, the created that, the updated that. Now you can see the data type which each of these attributes carry. The email carries a variable character which telling me the maximum length is 255. The created at carries a timestamp, which is basically like a date. Now, when I have informations populated into this table and each of this column, it's difficult for me to come back and say, I just want to change the email from being a variable character to an integer. Like it's very difficult because the behavior of the SQL database does not support that flexibility so much. Now, I'm not saying it's not possible, but trust me, you're going to run into a lot of complications when you're trying to do that. Except for cases where we've had stuffs like migration. For those of you who build back-end applications and who build like real world applications that are being used in companies or startups or whatever, you definitely would have come across database migration, which are basically ways to manage your database types, entities, all of those stuffs. But in NoSQL, the schemas are very flexible. I can decide to make one particular schema of different type. I can decide to make it of another type. This can decide to be a JSON. I can decide to impute a JSON, an array, an object, a nested object, a nested array, whatever it is. Now, when we talk about scaling, which is another use case I want us to consider, In SQL related database, we've got vertical scaling, which scales up to a larger server. And in NoSQL, we've got horizontal scaling, which scales across commodity servers. Now, the difference you can see it, the scaling process in SQL databases are basically vertical, and it involves you scaling up, you know, to a larger server. So, for example, it's more like you expanding your server from the will I say what it's able to carry before, and based on your current use case, you can be able to expand that existing server. And for NoSQL, it's a horizontal approach where you have to scale out across several servers. Now, one other thing we're going to be looking at again is the joins. Let's look at the joins. Now, having to join in SQL is a default behavior. You know, when you're dealing with SQL database, you definitely would want to join. Let's go back to the SQL database. We've got a user schema. For example, if this was a schema called SQLized meta, and the ID of the SQLized meta is a foreign key inside of the user's table. So let's take, for example, we have another column here, which is called SQLized meta ID, which is basically going to be a foreign key. Now, in that scenario, when you want to populate data from the DB, you can decide to join the data coming from the user table to that of the SQLized meta table where there is a match. And the match here, or the relationship here, is basically the fact that the ID of the SQLized meta table is a foreign key in the user's table. So that way you can be able to do a join between the both of them. Now that is a default behavior in SQL. We've got stuff like inner join, outer join, left outer join, a lot of joins that's happening in SQL database. Unlike NoSQL, where we don't really have a join, but there are cases where you need to perform several joins. Now, this brings me back to my earlier stuff, which I talked about, considering what your application would require. Now, it's not a pretty straightforward approach for you to make joins in your database for SQL and for NoSQL rather. So that's where we have for MongoDB, for example, which is a NoSQL database, we have stuff like aggregates, we have project, we have several match, we have filter. Like these are different aggregate functions that can help you perform something similar to a default join behavior that is in SQL. One other thing I would like to explain again here is the data to object mapping. Now, this requires object relational mapping in SQL, and in NoSQL, you definitely would not require an ORM. MongoDB documents map directly to data structures, and I'm using MongoDB here as an example or as a use case for NoSQL, basically because it's like I wouldn't say the most popular, but it's a database that is widely known across several organizations, engineers, for NoSQL database. Now, that's basically like we have a lot of approaches, we have a lot of benefits to the both of them. We have a lot of things that you should consider, but most of these ones which I have explained to you are like key considerations that you should look at when you're dealing with SQL and NoSQL database. So in summary, we have the first thing, which is basically the data storage model, which basically the SQL has fixed rows and columns. The NoSQL deals with JSON, key value pairs, documents, table with rows, dynamic column, graphs, all of that. For primary purpose, we have general purpose as the NoSQL, and for the no for the SQL rather, and for the NoSQL we have documents that are basically key value. We have large amount of data, we have queries, we have analyzing of graph, traversing between different data. These are several purposes of why you definitely would want to use the NoSQL. One more thing again is the schemas, and I said earlier, I said the schema for the SQL database is rigid, which basically means it's kind of a bit more difficult to always want to change the schema of the SQL database, unlike the NoSQL, which is very flexible. And I also outlined and pointed out scaling, which basically for SQL you scale vertically, which is basically expanding one server, and for NoSQL you scale horizontally, which is basically scaling out across multiple servers. And I also pointed out the joins. For the SQL, you definitely would have a default behavior of joins where we've got the inner join, outer join, left outer join, and all of that. And for NoSQL, which doesn't have a default joins behavior, but for database like MongoDB, they've been able to introduce what we call the aggregate functions, which helps you perform something similar to join. There are several other use cases you should consider, but these are basically what I wanted to point out today. So for those of you who would always want to use the database you love, it's not always the case. It's always the case of you considering most of these things which I've listed out here. Let me know any other thing you feel we should add, any other thing you feel the audience should know, because I'm unable to cover up everything, because I know there are lots of things to also consider. So if you have any other thing you feel people should consider when choosing database, if you have any other benefits you feel a database have over another, drop it in the comment section. I would love to interact with it, and I would love every other person to see it. And I think that brings us to the end of this video. I would see you in the next video. Like, share, and subscribe.